video is made a little different than most of my other videos. Instead of doing it on the whiteboard, I'm going to do it on here so I can show you some stuff on the calculator. These notes are on Moodle. You could print them off if you wanted to, or you could just jot stuff down on your own sheet of paper, whatever's best for you. A lot of this is section 9.1b. So a lot of this is going back over the stuff that we covered in the last assignment. Just going back over it, and then we're going to add a little to it. So I'll go through a lot of it fairly quickly. Correlation we talked about in the last assignment. Correlation is a relationship between two variables. So we have our x's and y's. Usually it's an x and a y. It could be whatever variables. It doesn't have to be. One of them is an independent variable. That's usually the one that you're starting with. And then the other is your dependent variable. Usually your x is your independent, your y is your dependent. And all that means is if you know some x, like x maybe is 5, then we stick that into whatever it is that we're doing, and we get out some y equal to whatever. So the y depends on what variable you're sticking in or what number you're sticking in for x. Again, correlation, key idea here, correlation just talks about the relationship between those variables. Sometimes there'll be a relationship, sometimes there won't. We use correlation to draw a scatter plot. On this scatter plot can be used to determine if there is linear correlation between the two variables. On the last one, we drew in some line of fit that looked close to going through all the line or all the points. This time what we're going to do is we're going to actually learn how to draw in the line of best fit, or what's called the line of regression. And it's going to be the very best line that fits the data. Here to graph each of these points, if we looked at these first two right here, it's 1, -4. That's that point right there. We go to the right one, down 4, just making our scatter plot. We look at the next one, 2, -2. Go to the right 2, down 2, so on, all the way across. And again, if we drew in like we did last on the last assignment, we drew in a line that sort of looks like it fits that data. What we can do is we can make predictions off of that line. So if we wanted to come out here to where, and this would be extrapolation, that if we wanted to come out here to where x is 6, because we're outside the data that we were given, we could make some prediction on what y is going to come out to be over here. So if you're drawing a scatter plot, you're just graphing all those. In that, you have a domain and a range. Probably talked about domain and range before in other math classes. The domain is all the x values of the function, or all the independent variable values. The range is all the y values, or the dependent variables. Some classes, they might tell you to list your domain and range in parentheses, braces, brackets, whatever. In here, all we're going to do to list our domain and range, if I wanted to list the domain here, and I've already got it down there at the bottom, but I'm going to list it again, is we just look at the lowest x and the highest x. And all I want to know is that you know that the domain goes from 1 down or anything, they're just scattered everywhere. And then we had nonlinear correlation, which would look maybe something like this. It could have other forms too. We're not going to deal with nonlinear. Most everything that we do is going to be some kind of linear correlation, if it's got any correlation. On your calculator, so if I grab my calculator, you can draw the scatter plots on your calculator. I talked about this last time and said I didn't like it because it messes up your window a lot of times, but I'm going to show you how to do it on your calculator. You just follow these steps. So if I turn my calculator on, here, I go to stack, and I can go to edit and put in numbers in your list, whatever your numbers are. Put your X's in your list in the first list, Y's in the second list. It doesn't matter which list they're in, as long as you remember that the X's have to come first and the Y's come second. So you could put them in like the second list and the third list or whatever. If we go back to edit here real quick, remember if you need to clear a list, you can scroll down to number 4 and clear a list if you need to. I usually just delete them out on the list, but you can clear it that way, that's up to you. So if I go back up to edit here, I got numbers in my list already, list 1 and 2 that I want in there. Then you go to stat plot. Stat plot is right here. So what you have to do is you have to hit second and then hit this button, and it pulls up this screen. You hit enter. You want it turned on. It's usually turned off, but you want it turned on this time. So you go to on and hit enter. Then you go down to as you're going down, you see the types here. The first one right here is a scatter plot. That's what we want. The others, you have like a box and whiskers, so on, so on. You have a histogram or a bar graph there, and different kinds of graphs that you could do, but we want the scatter plot this time. Put in your list, list 1, list 2. The last thing down here is just telling what kind of point you want each ordered pair to make. I leave mine on the box just so I can see it. These other ones are a little small. You might be alright with those, but that's up to you. Once you have that, once you have all that in there, you go to graph. My graph is right here. It's this button underneath the screen, but my work graph is sort of wore off. You push that and it's going to graph it. You'll notice that you don't see anything on my graph because my window's not set right. And what I need to do is go to window, which is right here, it's this button, and change my X and Y minimums and maximums and the scales and everything until I can see all of the data. And I'm not going to do that. I'm not going to change mine because that's the part I don't like to go back through and have to reset it all the time. But that's how you could do your scatter plot on your calculator. And if you do your scatter plots on your calculator, then you could just sort of transfer them over to a piece of paper. So if you have a graph on a piece of paper, you could just sort of look at your calculator and see where they're at, put in the points and everything, and make sure you label your X and Y axes and so on and so on. Alright, the rest of the lesson talking about regression line or line of best fit. To write a regression line, we're going to write it in the form y equals mx plus b, which is your slope-intercept form from algebra. M stands for the slope. B stands for the y-intercept, where the line crosses the y-axis at. This says, after verifying that the linear correlation between the two variables is significant, we're going to skip that part for right now. We're going to do that next lesson. We're going for now, we're just going to assume that there is in there thinking it was close to being that line of best fit. To get that line of best fit, first thing you have to do is you have to find residuals. And what a residual is the difference between the observed Y value and the predicted Y value for a given X value on the line. So we're looking at this line, and last time we just drew in whatever line we thought was close. To get the line of best fit, what we need is we need to find these residuals, and all the residual is if we look at this point right here, that's the actual point, or the observed point, the point from our data. And then if we draw in our line of fit, this is the predicted point, or what we would predict the that Y is going to be at if X was whatever it is right there. Well, we want the difference in those two. And we take each one of those for every one of the points that we had in our data, and we find that difference. How far off of the line of best fit is each point in the data? So you can see if there's only a few of these points, then, like here we have 1, 2, 3, 4, 5, 6. There's only 6 of them. Well, that wouldn't be too hard to subtract 6 times. But if we have 600 points, then that starts to get into a lot. And most of this stuff we're going to do on the calculator, but I'm going to show you what it means and how to do it out in longhand first. So that's what a residual is. A residual is just, again, the difference between what you've seen in your data and what the predicted value would be using that certain line of fit. Again, the regression line, or the line of best fit, line for which the sum of the squares of the residuals is a minimum. So it's the smallest sum possible. So what all that's saying, if we go back to this one, and we look at this, and we find this difference, we find this difference, we find this one, we find this one, we find this one, find that one. And what we would do is we would take each of those differences and we would square them. And once we square each one of those differences, everything's going to come out to be a positive. So we square them all. And then once we square all of them, we add them all up. So once we square them, then you just add up all those answers. And when we get our line of best fit, or our regression line, the line that it actually should be, not just one that we guessed at, that sum is the smallest possible sum. It's got to be the smallest possible sum. So you can see if we just drew in some random line here, and then we drew in some other random line, and then some other random line, and some other random line, we could be here for a while trying to figure out which one has the smallest sum for all those residuals. The equation of the regression line for an independent variable x and dependent variable y is y hat equals mx plus b, again where m stands for the slope, b stands for the y-intercept. And we're going to figure out the best slope and y-intercept, the slope and y-intercept that goes with the line of best fit. To find the slope and the y-intercept, we use these two formulas. Those formulas, they look sort of difficult, but you just have to remember what each thing stands for. N is the number of entries in your sample. That symbol is your summation symbol. So this one's telling us to add up all the, we take all the x's times its y, and then we add all those up. And I'm going to show you a chart for this up here in a minute, like a chart that we did at the start of the year to help you do this. that we got from over here, whatever this answer is, we stick in there, and we do this answer minus the slope times that answer. These formulas, they look really hard, but if you do the chart, they're not really all that difficult. Remember that X bar means the mean value for the X's, well, Y bar means the mean value for the Y values. So Y bar is just the mean of the Y's, X bar is the mean of the X's. Whenever you're drawing this, if we're doing our line of fit here and we have our set of data wherever all these points fall at, our line of best fit, our regression line, somewhere on that line is always going to be the point that's the mean of the X's and the mean of the Y's. That point is always going to fall somewhere on that regression line. This is the chart I was talking about to help you do the formulas. I'm just going to show you just a quick example here. If I just put in some numbers, 1, 2, 3, 4 for X, and then we could do the Y's. Let's say Y might be something like 2, 4, 6, and 8. I'm just making up numbers to show you this. We could work out and do this chart, and that's going to help us do these two formulas. So if I look X times Y, just take and we did charts like this early in the year. So if you remember back to those, it shouldn't be real difficult. X times Y, 1 times 2 is 2, 2 times 4 is 8, 3 times 6 is 18, 4 times 8 is 32. Next one, the X squared, well 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, the Y squared, 2 squared is 4, 16, 36, 64. And then at the bottom here, we just want the sum of each of those columns. So here we do 1 plus 2 is 3, plus 3 is 6, plus 4 is 10. So the sum of all the X's is 10. Sum of all the Y's is 20. We add all those up. Here this is 50, 60. This one, that's 5, or let's go 10, 14, 14 plus 16 is 30. This column we really don't need right now. We're going to need it next time. So I'm not going to bother with adding it up right now. But because we just need these first 4 columns. If we come down here, our n this time, we have 4 terms. So that's our n. And we could just plug into this formula. So it'd just be the slope equals 4 times the sum of X times Y, which is 60, minus the sum of all the X's, which was 10, times the sum of all the Y's, which was 20, divided by n again is 4, times the sum of all the X squareds, which was 30, minus the sum of all the X's, which is 10, but then we want to square that. We do all that math there, and that's going to give us the slope of our regression line. We come over here to this formula. We just take the sum of all the Y's, which was 20, divided by n, which was 4, minus the slope. That's going to be the answer that we get right here, if I would have done that math, times the sum of all the X's, which is 10, divided by the number of X's, which was 4. We do all that, and that's going to give us our y-intercept. So then we could just write the equation, y equals whatever this slope is, times x, plus whatever this b is, when we do all the math. That's what you do if you do it out longhand. Again, most of the stuff we're going to do on the calculator, but I'm going to show you a problem, work it out longhand, and then I'll necessarily pollution, but that's sort of what it's talking about here, how much pollution they're putting into the air. So if we look at this, you got this country or this city or whatever it happens to be, has a GDP of $1.6 trillion, and their CO2 emission is 428.2 million metric tons. And all we're doing is matching those up. What we're going to do is we're going to make the chart for this, and you can see that with these numbers, making that chart is going to be a whole lot harder than it was when I just picked 1, 2, 3, and 4, and 2, 4, 6, and 8, because now we got to take all these numbers, add them up, all these numbers, add them up, take this number and square it, write down that answer, so on, and then add all those up, take this number and square it, add all those up, take this number times this number, and multiply all up, or add all the answers there, so on, so it's going to be quite a bit harder. This is what the chart would look like if we did do it all out. Got all these, you got your x's, you got your y's, you got x times y, each of the x's squared, each of the y's squared, and then down here I added them all up. Again, this column here, the y's, we're not actually using it right now. We're going to use it on the next section, but not this section. But we need all these numbers to plug into our formula to find the slope and the y-intercept. This is what it looked like if I took all those numbers. I have my sum of my x's, sum of my y's, sum of the x's times the y's, the sum of all the x squareds. And if I plug into the slope formula, I end up with this. Then I plug all that into my calculator, and I come up with the slope is 196.151977. Then once I know that slope, I come down here. All my y's added up to that. There were 10 in our sample. This was our slope. Our x's added up to this number. There were 10 in our sample. I do all that math, and I come up with that number. That's the y-intercept. That's where the line crosses the y-axis. So to write our equation, we got y equals mx plus b. We're just going to plug in the slope that we found in place of m. And we're going to plug in right here in the b, the y-intercept that we found. And this is the equation that we would get. So this is the equation for our regression line, for our line of best fit. I know it didn't look too difficult there, but if you had to do all those numbers in that chart with the crazy numbers that it had, especially out here, you can see that it gets a little bit difficult, and you end up with some big numbers and some stuff that you have to add up and get quite large numbers. So instead of doing all of it that way using the chart, we're going to use a calculator most of the time. One other thing that I want you to know for sure though is if this is our regression line, our line of best fit, you got to be able to explain what that means. So when we look at this slope right here, and it's sort of hard with this one because a lot of the GDP and the CO2 emissions might not make a whole lot of sense to you. It probably would make more sense on a different graph if we were doing something like comparing, or if our x variable was your height and your y variable was your weight, comparing those two, that might make a little more sense. But to explain the slope, with this slope right here, the 196.152, that's just saying for every $1 trillion of GDP, remember, and I should say this first, remember with your slope, 0.152 over 1. So we're saying as our x goes up 1, our y's go up about 196. So what we're saying here, for every $1 trillion, that's how much the x is going up. So each time the x goes up $1 trillion, then the CO2 emissions goes up about 196 million metric tons. So if we were looking at something that had height compared to weight, and our slope maybe was 1/5, and this isn't I probably should make it, let's make it a little, our slope is maybe, it's not gonna come out all nice and even like that all the time. So let's say it is 1/5. Then what we're saying here is, for every 5 whatever we go up, maybe it's 5 centimeters, your height goes up, your weight goes up 1 kilogram. So that's what the slope there is telling you. So if you had another slope, maybe your slope was 3:2, you're saying for every 3 whatever, your y goes up, your x's go to the right 2, or I sort of said it backwards there. For every 2 that you go up on your x-axis, or you go to the right on your x-axis, you're going to go up 3. If we had a negative slope, so something like -1/2, we're saying for every 2 that your x goes to the right, your y goes down 1. That's how you're interpreting that slope. Whatever's on bottom, and if we have a number like this, then it's always going to be a 1 on the bottom. So every time the x goes to the right 1, the y moves 196 up. Now the y-intercept is where our x is 0. That's where it crosses the y-axis. So we're saying the GDP of that country or city or whatever is 0, then the CO2 emissions for that country would be about 102 million metric tons. Again, this is an extrapolation. We talked about extrapolation, and I'm going to mention it again here in just a minute. This is an extrapolation because we didn't have any countries or anything in our data that said that the GDP was 0. So we're predicting outside the data. So this one with extrapolation, a lot of times extrapolation doesn't always make a whole lot of sense, and it's not a good way to predict something. Because if a country had a GDP of $0, well, their emissions probably aren't going to be 102 million metric tons. So with extrapolation, it's not always a good way to predict everything. But to explain your slope and your y-intercept, that's what you do. This is just a graph. This is our scatter plot of that information with our line of regression or our line of best fit drawn in. Notice when you draw this in, you have about the same number of points on top as on bottom, and then it hits some of the points. You want to hit as many as you can with a line of regression. You want it to hit as many of them as possible, and you want about the same number on the top as on the bottom. We're going to do another one here real quick using our calculators. So using the technology, we have this set of figure out how to write an equation for that regression line or that line of best fit. So I have those data, I have them all in here, and all you're going to do I thought I had a list here, so, and I can't find it, I'm gonna add it, I'll add it to the notes, but for now, I'm just gonna, put it in here. So this is to write an equation. This will give you just the steps to write an equation, for your regression line. So it's finding the slope and the y-intercept of that regression line. So first thing you gotta do, you gotta put your numbers in the list, like I have here. So put X in list 1, put Y in list 2, which I've already done. Then you're going to go to stat. Over to calculate. Once we're on calculate, we want to go down to number 4, which number 4 on my calculator says linear regression, and then it gives you AX plus B. I think some of the calculators might just say Y linear regression, then it might say Y equals AX plus B or something like that. There's another one on down. We don't want it. We want the first one here, the one that says, see this one on down. We don't want it. We want this one. It doesn't really make a whole lot of difference, but we want to stick with everybody doing the same thing. We want the one that says AX plus B. So A is our slope, B is our y-intercept. On my calculator, again, it's number 4. So I hit enter. Once you're on number 4, you hit enter. Then it pulls up this screen. And you got to hit second and put in your list that you used. Well, I used list 1. So put in list 1. Then you put in, sorry, not list 2. Then you put in a comma. Comma is right here. It's just above the 7. And then you put in, you hit second, and then list 2, which is right above the 2. Then we're going to hit enter. And it pops up and it tells us y equals AX plus B. It's telling you that A is your slope, B is your y-intercept, and it tells you what A is, 12.478, so on, so on. It tells you what B is. And then it also gives you these other two numbers, which is R squared and R. We're going to talk about those a little bit next time. For now, just know that you want the R squared and the R. You want to be able to find them. Now, if you didn't do the diagnostics on the other video that I sent out for your calculator, if you didn't do that, then you need to do it. Otherwise, it won't tell you the R squared and the R. So now, once we the equation of our regression line. The R again, we talked a little about R last time. The R and the R squared, we're going to use them. For now, all I want you to do is just be able to write down what R is, so 0.9786, something like that. And then R squared is 0.957, we'll round it to 7. So just be able to write those down. These are your correlation coefficient. And that's just telling you how well the data is correlated. And we're going to, again, we'll talk more about that in the next lesson. But for now, just be able to write them down. If you didn't do the diagnostic, what you need to do the diagnostic to get so that it shows you R squared and R is you got to hit second, 0, and then you go down to diagnostic, scroll down to the D's, and where it says diagnostic on, you hit that, hit enter, and then you hit enter again, and it'll say done, and that turns on the diagnostic so that it will show you the R and the R squared. The last thing here was just to hit enter. So those 10 steps, I'll put those in the PowerPoint. I thought I had them in there, but apparently not. And you can see when they did it in the book, they came up with 12.481. They went out extra space from what I went out, and 33.683. I think I had 33.68 something else. I had 33.687, so I rounded up. But it's going to be somewhere real close. Remember that interpolation is when you're making predictions inside the data that you're given. So you're making predictions into that domain that you're given. Extrapolation is when you're making predictions outside. So if I was given a domain that was 17 to 38, this is our x's. The lowest x is 17, the highest x is 38. If I'm predicting for 34, well, that's inside there somewhere, so that's called interpolation. If we were predicting for the number 7, which is outside, it's called extrapolation. 7 doesn't fall in between there, so it's extrapolation. Again, extrapolation, not always the best way to predict something. We did this last time, but they gave us this just to refresh your memory a little bit. Now I'm going to show you just this one example. It says predict if you had a GDP of $1.2 trillion. All you would do to make a prediction here, once you know the equation for the line of best fit or the regression line, is you take the x that you're wanting to predict at, you stick it in place of x right there in the equation, and then you can just plug all of that information right into your calculator. So if I put in 96.152 times 1.2 plus 102.289, hit enter. That's telling us that the y, where x is 1.2, the y would be about 337.6714. So going back to that this would be the CO2 emissions. It would be about that if the country or whatever it is had a $1.2 trillion GDP. So that's just making a prediction off that. Same idea here. Here, to make the prediction, we just stick in 2.0 in place of the 1.2. here, 2.5 in place of the 1.2. And all of this would be interpolation, because it's all within the data that we were given. Here's just the answers if we did all of that. The one that we just did, 337.671, that's what we got when we did it on our calculator. So on, so on, so on. Next time, again, we're going to deal more with the correlation coefficient. That's R. For now, all I want you to know about is R is called the correlation coefficient, and we can use our calculator to figure out what R is.